Good morning and welcome to this webinar. Hi, my name is Kevin Wong and I'm the Director of the Desert Institute at Joshua Tree National Park, which is the educational program of the Joshua Tree National Park Association. With me is Lara Roselle of the National Park Service, who originally proposed this series of webinars to train park staff on park-specific topics while they are working remotely during this pandemic. We will be your hosts and the producers of these webinars. Before we get started, I would like to offer some tips on how to use this webinar effectively. As internet bandwidth is heavily used in California due to the stay-at-home direction, and so many of us are working remotely, we may have issues with internet connections. If you have audio or monitor issues during this webinar, it may be due to having too many programs open on your browser, including email or Facebook, which have regular updates. These will reduce your access to bandwidth, so you may want to shut them down. In addition, when the webinar begins, you will see a small control panel on your screen, generally in the upper right corner. There is a question mark and a dialog balloon, and if you click on the question mark, you can ask questions that we will present to the speaker during his presentation. We will also unmute the audience at the end of the presentation so you can ask questions. Please try not to ask all your questions at the same time. At this time, we will begin. Today's presentation is Climbing Bolt Replacement Program in Joshua Tree National Park with Kevin Powell. Kevin, thanks for being here today.
All right, Kevin, thanks for having me. Good morning, everyone. My name's Kevin Powell, and hopefully everybody can see the screen and see it. I put a picture in here so the people that don't know me kind of get an idea of what I look like. Anyway, I'm a locally based rock climber, photographer. I'm retired from CAL FIRE. That was my career. So this morning, we're going to talk about replacing fixed anchors or climbing bolts in the park. And the presentation is kind of slanted towards people who have climbed before and have some knowledge of the use of fixed anchors. So we'll go ahead and start. The presentation is called What's Behind the Hanger. And as you can see here, this first bolt, this is what a climber might see when they're on the rock climb, and they're going to clip into this fixed anchor. These anchors are placed by the first ascent party. They're either drilled with a hand drill and or in modern times, possibly a power drill. But the goal behind this presentation is so people can understand exactly what the fixed anchors are, how they're integrated into the safety system that the climbers use, and also to see basically the condition of the fixed anchors that have been placed in the park since about the 1950s, but mostly we're focusing here on stuff that was placed since like the early to late 70s on. So anyway, so if I was climbing, I might climb up and I might see this bolt here and I think everything looks good, there's a stainless steel hanger, there's a bolt, I don't see any rust or corrosion on it. And then when I remove it, of course the general climber is not going to see this, but this is what's behind the hanger. And you see this is a hardware store anchor, has noticeable rust and corrosion, which can greatly reduce the holding strength of the bolt. So with that, this is what our presentation is going to cover. We're going to look at the fixed anchors. I'm going to talk a little bit about the past. I'm going to show you some stuff that's been going on in the last 4 years here in the park. And then we'll talk about maybe what the future of fixed anchors in the park is going to be. So why do we want to replace these fixed anchors that have been there for, periods of time, anywhere from 5 to maybe 45 years or so? It's a life safety device placed by the first ascent party typically. They get to choose what kind of bolt, what kind of anchor they're going to use, and then they drill a hole in the rock, like we said, either by hand drill or by a power drill. And then they pound it into the rock, and that becomes one of the life safety pieces that the thousands of climbers that come through the park every year potentially use, depending on the climb they pick. So why do we want to replace the fixed anchors? Because we want to increase the life safety capabilities of the anchor. They need to be maintained. They're like anything else, and with the large influx of climbing over the last 10 years, these fixed anchors are getting used more and more by the climbers, so they're tending to wear out and more stress is being put on it. So they're heavily used. And one of the big things here in the park is we want to try and reduce the visual presence of these fixed anchors. Climbers aren't the only ones that see them. So if we can take out the old rusty ones and put in new all stainless steel anchors with a bolt hanger that's painted or coated towards the general color of the rock, we reduce the visual presence. And that was one of the reasons that I got into doing this 33 years ago, was to maintain the anchors and to reduce the visual presence of the rust streaks and stuff. So the bolt, people will ask us sometimes when they see us, they go, "How do you know that bolt's bad?" And I'll say, "Well, how do you know it's good? Because you can't see what's behind the hanger." So like your rope, do you climb on your rope until the rope actually breaks? Hopefully not. And that's the whole thing with replacing these fixed anchors, is we want to try and eliminate any potential failures of the fixed anchors, so there's not a catastrophic event in the park where somebody gets injured or killed. So I began bolting 33 years ago. Me and a couple friends, we were probably the first people in the United States that started doing this on a larger scale. We started replacing bolts out here, up in Idlewild, and other places. I've replaced bolts up in the Owens Valley. I've replaced bolts up in Canada. So I have a fairly extensive history with doing this. Initially, we purchased all the hardware, all the bolts, hangers, the quick links, the rappel rings. We purchased all of that through our own resources, our own funding. Me and my friends, we contributed a lot of our own time to do this. It was a project that we decided to do. We started out, we just wanted to replace anchors that we thought were key. If that bolt failed, maybe you would take a 50 or 100-foot fall, possibly die. And as soon as we started working on this stuff in May of '87, we quickly realized that we couldn't just replace the odd bolt. We had to do them all. So that's what we started doing. Back then, there was no real hardware standard established for the hardware. We bought what we could. We upgraded everything that was in existence. And that's how I got into doing this 33 years ago. And this is the tools we used to use back then. The top elements are these here, if you can see my mouse cursor, these are pitons, and these are designed to be driven into cracks in the rock, but we modified these here to help us take out the old style bolts, which we'll see here in a couple of frames. And this is the primitive removal tools that we used back then. We didn't have access to the tools we now have here. One of the things that the Joshua Tree community is very fortunate to have is a guy named Mark Wagner, who's a retired engineer, and he's put a lot of time and a lot of his own money and efforts into designing tools and techniques to get these bolts out. Because our goal is to do hole for hole to minimize the resource damage. So the goal is to take out all the old metal out of the existing hole and then to enlarge it and put in a new all stainless steel anchor. So I can tell you that I talk to people from all over the U.S. about bolt replacing, and the tools that Mark has designed and built using his own money, and he's probably contributed just himself about $30,000 with materials and labor towards this project. And we'll see at the end, I basically have outlined the cost for our volunteer hours if we were paid $30 an hour. And we'll get down, and I think you'll be pretty surprised at the amount of money that's went into replacing bolts. And this is just in the last 4 years. When Mark started, me and him got started on June 30th of 2016. Anyway, here's some of the tools he's designed. This is some of the gear. Maybe not all of this goes, but a large part of this goes with us. So when we go out, sometimes it's just me and Mark. Other times, we have other individuals that will help us, the climbing stewards, other people in the general climbing community. So we have to get all this stuff to the base. It's very gear intensive because there's different types of bolts that need to be removed, and there's different techniques that are required to remove them. So here's a couple of the tools that Mark has designed for removing bolts. These are pullers. And both of these, if you probably paid an engineer design time and then the fabrication time, these tools individually would probably sell it from anywhere from $10,000 to $15,000 each. He's very adept he has his own fabrication shop at his house. He's very experienced with using all types of exotic metals. So he designs and then he builds these pullers that we use out there. Okay, this is one of the pullers. This is a practice area. He has rocks on his property, and this is where he will go out and practice using the different tools to make sure they're going to work before we actually take them out, onto the rock climbs into the park. I'm not going to talk about the technical components of the pullers because I didn't design and build them, but he can basically roughly pull with these pullers about 10,000 pounds. He can put about 10,000 pounds of pulling force on these anchors if he needs to. Okay. This is one of the pullers that's attached to a bolt that's in the rock. You can see the hanger here. This is the actual bolt that's in the rock here. And then once he gets this all set up, there's a mechanical advantage exerted by the handle in turning the device. I want to say it's 90 to 1, but I might be incorrect on that. Okay, here's just another view of the puller being used. And this is called the button head puller. And the other one's just the main puller. So these are designed to pull different types of bolts. They won't work on every single bolt. They work on a specific type of bolt. Okay. So I threw in some stuff here. Some of you might know that I'm a photographer here, and I specialize in photographing the bighorn sheep. So there's going to be a series of these photos that show the sheep climbing up this rock face here as we go through the program. Okay, so Echo Rock, out by the Echo T parking lot, there's a fairly well-known route called the Stichter quits. And this is one of the original protection bolts that was placed on the Stichter quits in November of '72 when they did the first ascent. And this is called a star drive bolt, and it's a nail with these two lead sleeves with a leaper hang. So I first replaced this bolt back in November of '88, and then the second replacement we did with all stainless steel was in July of 2016. Are there bolts like this still in the park? Yes, there's hundreds of these same type of bolts out in the park. They're mostly in the more obscure areas or out in the wonderland of rocks, places that people don't typically go. And these will be the ones where we'll probably have, some type of a catastrophic failure sometime in the very near future, 3 to 4 or 5 years. I think we can pretty much safely say that. And I'll show you something near the end of the presentation that will really drive that point home. Okay, here is another bolt, same different style bolt, different style hanger. This was placed on Saddle Rock on a route called Cheap Way to Die in February of '80 during the first ascent. And then this was replaced back in July 2001 by myself and Bob Gaines when we were doing some replacement work out on Saddle Rock. But you can see the amount of corrosion on the bolt and the hanger. The way this hanger was designed, it was designed with a metal called chrome moly. It doesn't have a high resistance to corrosion. So once again, the corrosive action on the metals just start to weaken them slowly over time. And once corrosion starts, it never stops. Okay. Here is a bolt. This is just a modified machine bolt that was filed down and then just tapped into the hole. The only holding power for pulling straight out on this was just the friction of the bolt on the sidewalls of the hole. This was placed on the first ascent in 1983, and then we replaced it in 2016. So once again, you can see the hole behind the hanger thing. All you would see is the head of this thing. You wouldn't see what's here. You don't know what's back there. Okay. You're just taking the chance that whatever you're clipping into is good. Okay. Here's a bolt hanger. This is called a leaper hanger, and this was removed on a route on the Astro out in the Wonderland of Rocks. And the people that were going to utilize this for a rappel so they could get down. The guy clipped in a quick draw, a piece of climbing equipment, and pulled on the hanger and snapped the hanger off. What had happened was these hangers, when the guy made them at Leaper, the tempering process of the metal, there was a flaw in that, and so what happened? These things would crack, and this thing cracked right along here, but you couldn't really see it. And had they not put upward pressure on that hanger, they never would have known that the hanger was bad. And that's the other the deal with replacing these fixed anchors is you can't tell what's good and what's bad. And we go back to my comment originally where people will ask me, how do I know that bolt is bad? And then I just tell them, well, how do you know it's good? So anyway, so here's a bolt. I replaced this bolt. I put this bolt in back in November of '98 on top of the Headstone out by Ryan Campground. And you can see this is a non-stainless steel bolt and stainless steel hanger. And that's, back then we did what they called mixed metals. And we went, this is some of the first things that me and Mark did together. We replaced this bolt in July of 2016, and I was fully amazed at how much corrosion was on this anchor. It didn't sit in a solution pocket. There was good drainage for when it rains. People always say you don't have to worry about this out in the desert because it's an arid environment. Well, here we have the proof right here. Okay, so this bolt was in, what, not quite 28 years, I guess. So once again, what's behind the hanger? See, this is what you see out here. Everything looks pretty good. It's corrosion up here, corrosion on the washer, but look at all the corrosion down here. So this is another anchor on top of a Headstone called the Cryptic Anchor. These are what they call a welded cold shut. And these are just a cargo hook that you would buy at a hardware store and put on your truck bed if you wanted to secure hardware. You know, they can be used for that kind of thing. So this is what the anchor was like when me and Mark got to it. Okay. This is what it looked like inside. You can see all the corrosion here. And one of the components of how the bolt is held in place by the mechanical action, this had just all fragmented away inside the hole when we were taking it out because there was so much corrosion on it. Okay, this is what the new anchor looks like. And you can see we've used rock-colored hangers in the bolts, so it blends pretty well into the rock, much lower profile, much stronger, much more useful for the climbing community, especially the high use that's happening now. And the descending rings, the rappel rings here, we can go back up because they're on with a quick link. We can unscrew that quick link if the rings start to wear and put a new ring on there. So it makes the sustainability a lot higher. Okay, here's just the sheep showing their natural ability for climbing. Okay, so I'm going to talk about now some stuff that was pretty concerning when we got to it. There's a climbing wall out in the real Hidden Valley, over by the Hidden Valley picnic area called the Thin Wall. Very high use area. People go there all the time. You can see 20 or 30 people there on any given day, not uncommon. So there was an anchor, a bolt anchor called Count on Your Fingers anchor. And so when we went up there to replace that, we noticed that the rock that the bolt was placed in wasn't of the best quality. Okay, so when we put the puller on the bolt, the bolt pulled out with a little part of the rock with about 300 to 400 pounds of outward or axial force pulling straight out on the anchor. This is one of the first really scary things that we found doing this because it's such a high use anchor, and we could have had a catastrophic failure of this bolt. So we think a couple of the things that might have contributed to it was the substandard rock quality that the anchor was placed in originally. And then these bolts they get a lot of dynamic loading on them. When people are lowering and climbing on them, they're bouncing on the rope. So it's almost like a little vibration on the bolt. So it's called microchipping. And we think that microchipping may have been part of the reason why the poor rock quality maybe even got worse because of this microchipping. I mean, it's just speculation. And that along with weathering. The bolt threads were damaged from high use. I'll show you that here. You can see where these threads here are damaged. This is the actual bolt that was in the rock. It was placed, my best guess was the early 90s. We replaced it in August of 2016. But this was kind of an eye-opener because there was a couple other people there with us. And, you know, when you first see this stuff happening, you kind of don't believe it because everybody has such an inherent trust of these fixed anchors. But that's the whole goal behind replacing the fixed anchors. It's just to increase the security of the anchors and, like I said, also reduce the visual presence and increase their sustainability. Okay. So there's another route not too far from here on a formation called the Sentinel. You're probably all familiar with that large formation there in Hidden Valley. And when these bolts were removed, if you notice, there was narrowing in the shaft of the bolt. Now, once again, here's the hanger. This is what you see when you clip in. You don't see any of this back here. But this bolt was slowly corroding away in the middle. How much longer would it have taken to completely corrode? That's purely, be purely a guess. But once again, what's behind the hanger, you can't see. And this is what was behind the hanger. And here's a close-up view of it. Note the narrowing due to the corrosion. Okay. This here was placed on a climb called the Pincher in Echo Cove, another really high-use area, pretty high-use climb. And you can see it was only 17 years old, and you can see the amount of corrosion down here. And the way this bolt works, this is called a contraction anchor. When the bolt is pounded into the rock, these little splines here contract, and then the outward force that they exert on the sidewall of the hole is how it gets its holding power for pulling straight out. So you can see, only 17 years, you can see how much corrosion. And this is on overhanging rock, so water's not sitting there. It's not sitting in a solution pocket. Okay. This bolt here failed while a climber was using it. Unfortunately, he was clipped to 2 above it, and when he fell off, this bolt was the first one on this route called the Jane's Addiction, and it pulled right out of the hole. You can see there's not much compression on these tines here. And that's because the rock quality there is a bit suspect. So these metals, when you pound them in, they require a lot of force on them to pound them in. And if the rock quality is not good enough, then these things don't compress. Okay. So you don't have as much holding power, straight out holding power as you would normally. So we replaced that in December of 2016. Luckily, if he had been clipped to that, and that was his first bolt, and he fell, there's a high chance it could have just pulled out and he would have hit the ground. Okay, here's a route. It's kind of out by Barker Dam, called the Father Figure. And this bolt here, I'm going to guess, my best guess was mid-90s. This bolt didn't actually fail, but the climber that reported it to us, he had replaced bolts before. He was familiar with this type of thing. The bolt was loose in the hole. He pushed it back in. He retreated from the climb. He told us about it. We got a special permit, and then we went out and we replaced it. But see, once again, see this hanger, everything looks good. There's a little corrosion on the head, but look at all the corrosion back here on this anchor. Okay, this is something that happened recently, and this is another big eye-opener. This happened back in November. We were out on the IRS wall in Hemingway, the Hemingway buttress area, and we were replacing an anchor on this route called the Taxman, another high-use route. All went well there. Everything was good. And then we decided to swing over and pick up these bolts on this route called the Bullet Head. So we reconfigured our anchor. We dropped down, and when we went to remove this, we only exerted about 100 pounds of force, and this is what we saw. The whole bolt had corroded through, and the only part of the bolt that had good metal was right here. You can see where the arrow is pointing. So that was another eye-opener. We had some people that hadn't done this, hadn't replaced bolts before, and they couldn't believe it. But this type of bolt, it's called a 5/16 button head. And there's probably about another 400 or 500 of these in the park right now. So we just know that there's probably a couple more of these with the same type of corrosion. And this same type of bolt had the same exact corrosion, was responsible for a fatal climbing injury up in the Owens River Gorge about 5 or 6 years ago. And I had pictures, I got to look at pictures of that bolt that failed, and it was basically had the same type of corrosion mechanism going on with it. Anyway, so here's another interesting part about when we were doing this, was this bolt was placed in the 1990s. And here you can see, it's not a close-up view, we saw that, and this is the other parts of it. But here's the same type of bolt. It was about 5 or 6 feet above it in a straight line. So the water drainage would be roughly the same. They were in a straight line. And you can see there's no corrosion on this bolt. And this is a stainless steel hanger, so there wouldn't be any corrosion on that. Pretty telling, pretty eye-opening to see the difference of something. They're just, only a few feet apart, and how differently the two, the metals, which are the same, corroded, this one corroded at a much higher rate, and this one hardly at all. And then this is the type of anchor we're putting in typically here. This is an all stainless steel bolt and hanger. These hangers are powder coated this tan color at the factory in Spain. So they blend in pretty well with most of the rock here. Okay, so here's just an example of this bolt was removed by a technique called spinning, and we use a power drill. And the bolt is, the drill is attached to the thread ends of the bolt, and it's spun until we spin it out of the hole. And this is what the hole looks like after we're done. And here we are enlarging an existing hole, and this is on a climb right on. But anyway, this is the use of the power drill. So we get a special permit through the park, so we can use the power drill here, and we can only use the power drills in non-wilderness front country. No wilderness use of the power drill. So here's our standard for replacement. This is what we typically use. So if the rock is of not the best quality, we might use a longer bolt here, you see. And if it's really good quality, we'll use a shorter one. And then we would use the longer one to try and get down to a better layer of rock. So when you're enlarging the existing hole, the guy that's drilling has to feel, at some point, does the drill suddenly drill like a 1 inch really quickly, and then go back into better rock? So when I'm drilling, I feel that, and I think, okay, I'm going to put in a long bolt because I'm going to get embedment down into the bottom of that. I'm going to go through that softer section down into that more compact, stronger section of rock, so we'll have a better anchor. So it's not just a matter of drilling a hole and putting a bolt in. Although a lot of people that place bolts nowadays, that's what they do, and we can tell some stories. If we have some time, I'll tell some stories about some of the other stuff we found out here. But anyway, this is our typical, this is what we're replacing with, and this is what it looks like. Okay, here's the desert bighorn doing a mantle move. He's almost on top, or she's almost on top. So when we go out to do this stuff, it's not, you can see here, they had to do quite a bit of rigging to get down to replace these bolts. It was very complicated. There was only 3 bolts. It took these guys, this is Mark, and this is the guy Doug. It took them almost 5 hours to replace these 3 bolts because of all the rigging they had to do and the difficulty in accessing these bolts and getting them out and then replacing them. So it's not, you don't just go out to throw the rope down, rappel down, pull the bolts out, and in an hour you've done 10 bolts. It doesn't work that way. Sometimes it might take us, an hour, hour and a half for 1 bolt to get it out. But we're committed to doing that because we want to maintain the integrity of hole for hole. And here's just another thing. You can see the complicated rigging they had to do to be able to get down in this sidewall to get these bolts out. This here was done in the summer, so we replace bolts all year long. In the summer, we just go out very early. We get out there just after sunrise. We get permits for stuff that's in the shade till about 10, and we replace in the shade, and then we go home. We've tried to get people to come out and help us during the summer, but so far we haven't been that lucky. Okay, so for you that work for the park, some of you might be familiar with the bolting regulations, but we put this in there. If I give this presentation, outside of these parameters where people aren't familiar with this, then we go over this stuff. So we talked about this. The power drill requires a special permit, can only be used in front country and non-wilderness. We only use it for the replacement of unsafe bolts. Bolting is prohibited in anchor-free zones. So the main anchor-free zone we would be concerned about here is that area when you walk into Barker Dam, basically from as soon as you get to the rocks till you're out into the open lake bed. If a route is within 50 feet of a cultural or archaeological site, we're not allowed to replace bolts there. All those routes have been closed, and there's usually a sign that says it's closed. If we go out to replace something, usually cultural has done a site inspection to verify there's no cultural artifacts that would be disturbing. If so, they won't issue the permit, or they could issue a permit with a variance. We have to stay out of these areas, and we totally abide by that. In placing new bolts in wilderness, like out in the Wonderland of Rocks, must be authorized by the park superintendent. That's only done by hand, and I think I'm the only one that's ever got a permit for that. There might be a couple other people, but anyway, Bernadette, the climbing ranger, went with me when we did this, and the guy Kevin Buckley, the law enforcement ranger that we used to work down here, and that was after the policy saying you couldn't use vegetation for climbing anchors. And this particular set of climbs used a pinyon pine as the anchor. So we went out there, we took all the slings and webbing from around the tree, and we placed a bolt anchor by hand. We hand drilled the anchor. And so we had a special permit, and we met all the parameters. So for the permit process, what we do now is I fill out a permit request, a special use permit, and then there's another form that goes with that where I list the formations and the climbs and the estimated number of bolts we're going to replace. And then I send that over to Bernadette, and then she takes it from there and goes through the process there for the park, which we'll see here shortly. And this is how the process, how it's been explained to me, through review by the Climbing Committee and the Wilderness Steering Committee, Cultural, Vegetation, Wildlife, Climbing, Administrative, and Law Enforcement. And once everybody signs off on the permit, then the permit is issued, and then we're allowed to go out and replace the bolt. So the permit process started back in 2000 when that new climbing management plan became effective. Then I got the first permit, and I had to go over to 29 and give a demo to Don Roberts and Ernie Quintana, who was the park superintendent there. So what I did was I hand drilled a bolt, a 1/4-inch bolt, and I placed the bolt, and then I removed it using the tuning forks, the primitive ways, and then I enlarged it. I enlarged the hole with a power drill and placed a new bolt so they could see, how the process went. So the permit would be issued for 1 day for one formation. If I didn't make it out there on that day, if I got held up at work or the weather pattern wasn't good, then the permit would have to be reissued. And that went on till about 2000, I think it was 5 or 6. And I happened to be on the Sawtooth Fire, and Don Roberts was there, and we were talking. And so we decided that he would give me a permit that would be good for a couple of weeks, so I'd have a window to work in. And then slowly over time, the permit went to being good for a month, and then a couple months, and now basically the permits are good until we complete all the work on that formation. So that's super helpful for us, especially if there's different weather patterns, or if we get held up and we can't go out there. Me and Mark are retired, so we can move the days that we go out there. Although we don't replace on the weekend. The park has asked us not to replace on the weekends, especially during the prime climbing time, which we totally agree with that, and we see the reason for that. So that's kind of how the permit process has gone. Pretty much typically now, a permit takes about 3 to 4 weeks to get. So that's a really nice turnaround time for us, especially if we have like an emergency situation where there's an anchor that's been judged, that's ready to fail, or could possibly fail in the near future, so we can get out and fix that before we have any problems with it. So here's just kind of a list of formations that we've done replacement work on. It's not inclusive of all of them. Not every route has a fixed anchor on it. Some are protected by natural or by just regular climbing gear without a drilled anchor. But a lot of routes do, and a lot of these formations have fixed anchors on top to facilitate the descent off the formation. So I won't read over all of them, but you can see, kind of the areas that we've tried to focus on, the areas that get the highest use, and the highest use routes. That's what we mainly focus on now. And then if we're in an area like the route where we had the failure back in November, it was a route that's not done very often, but we replaced it anyway, and we were glad we swung over there. So what does the future hold? Me and Mark, we have a standardized bolt that we use. Is that going to be the standard within the park? I guess there's really nobody else replacing bolts out here on a regular basis. Occasionally, some people will do some work, but mostly comes down to me and Mark doing the work. And like I said, with people helping us, once again, I want to emphasize that people do help us. It's not just two guys going out there, but we're the main impetus for the replacement work. So that's what we've decided is our standard. We'd like to see that everywhere, because it's those bolts are easy for sustainability. They're easy for us to go back and remove because they're not corroded in the hole. Even people without all Mark's sophisticated tools could probably figure out how to get them out and then just reuse the hole. So we have better sustainability. We're reducing the visual presence, and we're using all stainless steel. These anchors should be good for at least 50 years, unless just from high usage they just start to wear down. And that's just there's nothing we can do about that. We just have somebody's going to have to go back and replace them, because we're only we're not going to do this for too much longer, right? Because we're old. Okay, so here's a telling thing for you guys to look at, and this is I've roughly kept track of our hours and stuff, so these aren't finite numbers, but you can see here. So the engineering time would be Mark's engineering time for the tools and everything. So it comes out to if we build that out at $100, standard engineering rate would be $20,000. Tool production time and materials, his time of building, designing, building, and maintaining tools. You can see where that comes out to. Material cost $10,000. Production time and materials $30,000. Tool and equipment maintenance. When we come back, Mark has to maintain all those tools. There's a lot of moving parts inside, so it's not just come back home and you're done. So 28,000. The volunteer hours, roughly 3,600 hours in the last 4 years, times $30, $108,000. Volunteer hours for permits, miscellaneous, painting the hangars, doing other maintenance on the stuff, 6,000. Total donations by various organizations, roughly $20,000. The American Safe Climbing Association is what provides 95% of all the hardware that we use. They're a nonprofit. I just place an order with them. Greg, the guy that runs it, mails me the hardware, and then we use it. So we figure total, our time and all the people that have helped us over the last 4 years, 5,000 hours. It's probably a little low, but we figure the total cost for the project for the last 4 years about $222,000. Total number of bolts replaced 1,255, or approximately $175 per bolt for each bolt replacement. So that's a pretty telling figure. I don't think a lot of people realize the amount of time and money that goes into this. We're lucky that we have the American Safe Climbing Association that provides all the hardware for us. We're fortunate to have people that are willing to help us out. So it's worked out pretty good for us, for our little project anyway. So here's some of our supporters. They've either supported the project with either funding. Some people have provided Mark with some funding to pay for the expendable equipment that he uses, and then the rest of the stuff has been like rope donations or gear, or the bolts and all the related hardware. So we couldn't have done what we've been doing without all these people contributing in some way. So here's the top. Sheep's made it up to the summit. Joined her buddies up there. That's kind of the end of the show. We actually have a website. We occasionally get on there and update it, but it has a list that's relatively current of all the routes that have had bolts replaced on it. So if you go on there, and then we have some other stuff on there, and we're trying to put up some educational videos that show Mark's techniques for removing the bolts, so it can potentially be helpful to other people throughout the U.S. if they're doing replacement work as well. And then the American Safe Climbing Association. So if you care to donate money towards the replacement work, there it is, www.safeclimbing.org. They're a nonprofit. Like I say, they're the ones that provide all the hardware for us. And then I just threw in a couple slides for us to look at, since we can't actually go out to the park. These are just to remind us of what we're missing by the park being closed, but we're all in agreement the park should be closed. So okay, so does anybody have any questions about the presentation? Kevin, can we open that up, or? Hello?
Hey, thanks, Kevin. This is Laura, belatedly showing up, and I am going to go ahead and unmute the folks who are on. And so if you are on, please make sure your phone is muted. And if you want to ask a question, then go ahead and unmute your phone and ask a question. So just a moment. All right, so if anyone wants to unmute their phone, you should be able to do that. In the meantime, while people are thinking about questions, we have a couple of comments coming in. Rachel says, wow, thank you for your work and time. And Molly as well, enjoyed the presentation. Diana says, wow, love the pictures.
Hi, Kevin. This is Dave Larson. How are you? Hey, every once in a while, I get a question from an old timer who calls on the phone and they ask if they're allowed to use pitons. And I know that it's pretty rare, but I guess people, especially some really old school guys, will still try to place pitons. Do you have any, I know it's allowed, but do you have any thoughts on that?
Did Kevin get muted?
Kevin doesn't appear muted, but we're having a hard time hearing him, huh?
Yeah. Sorry for the delay there, David.
Kevin, if you're with us, you might want to try muting and unmuting your own phone.
Kevin.
Hey, you're back on, Kevin?
Yeah, when did I cut out? Just a couple minutes ago?
Oh,
Or?
David, do you want to repeat your question, please?
Sure. Hi, Kevin. This is Dave Larson. Hey, so it's pretty rare, but once in a while we get a phone call from an old school, old timer guy, and they ask, can I use pitons in the park? And I know it's allowed. I know people can use pitons, but do you have any thoughts on that?
Yeah, the thing with using a piton is, you increase resource damage to the rock by pounding it in, but more so by taking it out. So you'll see climbs where people they pound a pin in and then they leave it. It's called a fixed pin. But the thing is with the fixed piton is if you don't have a hammer to test it, you don't know how good it is. So if you're leaving it there for somebody else, especially now because there's a lot of inexperienced people, people are drawn to something that's fixed, like a piton or a bolt, and they just intuitively trust it without even knowing what it is, but it's there, so they just figure it's got to be good. So the thing with using a pin or a fixed pin, by leaving it, you put another link in the chain that could potentially fail. And people's own gear that they place on their own can fail too. But the thing is with a piece that you've actually placed yourself, at least you kind of have an idea what's going on with it, where the piton is kind of like what's behind the hanger. You can't see how deep the pin is in the crack or, what it's doing behind there. So I'll give you a couple examples. One that happened out here was a lot of times on these routes, when we're replacing them, if there's an old fixed pin on them and you can get new modern gear in, we'll take the pin out. So it reduces something in the safety chain where, there's just something else that could fail that's old. But we've actually just take a couple of taps on the eye of the piton, and the eye is just cracked right off of the blade of the piton. So once again, because they're not stainless and they're affected by the thawing and freezing action, they're affected by weathering just like the rock is, and that's the bad thing with using a piton. If you're going to use it, people aren't going to place it for free climbing nowadays typically, but they might place them for aid climbing, and then they usually remove them. So, it's not something that's highly used. I doubt you would see it be something infrequently used nowadays. Yeah.
All right, very good. But yeah, every once in a while, we do get that phone call. So it sounds like the best response if somebody's inquiring about pitons is number one, they're allowed to be used. Number two, we recommend against their use if possible. And number three, if they're going to use them, we want them to remove them when they're done climbing. Does that sound correct?
Yes.
All right.
Yes,
Very
exactly. Sounds perfect.
Thank you.
All right. Anything else? Are we good?
Oh yeah, we've got a few questions typed in.
Okay.
First of all, Bernadette says, you mentioned a bolt failing after a climber clipped into it. How many total failures have you heard of in the park?
Well, I'm trying to go back over the last 30 years or so. I've climbed out here since 73, so I don't know what that comes out to, 46 years or something. During actual use, there was one on the Astro about maybe 20 years ago. Bolt broke. The guy hit the ground, and I think he ended up breaking his ankle or something. That one on the Jane's Addiction. Trying to think if there's, Bernadette might have a better idea of that. But I will tell you some stories, is that we've during the replacement process, we've actually removed bolts by hand without having a mechanical advantage tool to remove the bolts. That's actually happened. And there was several anchors over in the Hall of Horrors area that were placed in very substandard rock, and these were Belay Rappel anchors, and so there was 3 anchors, 6 bolts that were all removed by hand. We didn't use a pulling tool or anything on them. We just we loosened them up a little bit with a wrench, and we start wiggling them, and they come out of the hole. So a lot of people that place these fixed anchors don't know how to place them, and they're not astute to testing the rock for the rock quality. They want to put it where it's the most convenient, but that's not necessarily the case. So what we'll do when we find those, we will move the anchors down to the best rock that we can find. It might not be the most convenient, but it's the safest option. And people just have to have a little bit more rigging skills to utilize the anchor, but the anchors aren't going to fail.
Okay,
so
I'm
does that
pain about hearing that you've been able to hand remove some of those. And that leads really well into our next couple of questions. Carly and Daniel both asked, how do we volunteer for bolt replacement, and including the summer?
Well, you would probably contact me, and you can do that through our website, or Bernadette has my cell phone number. You can just text me. So when people go out with us, we bring all the gear. They just need their personal climbing gear, their own harness, their ascenders, a rappel device, like a gree or something, but we have everything else. And so in the summer, we'll usually meet. The permits are good from sunrise to sunset. So if sunrise is at 5:30, we'll usually meet out there, right around 5:30. And it takes us a while to get going. We have to sort all the gear and get it loaded up. And so we usually start walking by 6. And most of the approaches are fairly short because we're all front country stuff. And then, we work for 2 or 3 hours, and then we're done and we come back. So yeah, I would probably say if they're park employees, probably just contact Bernadette if that's good with her, and then she can pass on my contact info.
Okay, sounds great. And Bernadette herself also asks, how many total bolts do you think there are in the park?
Boy, that's a good question. People have asked us that a lot. We know over the last 10 years, maybe 12 years, I have to go back. Significant number have been added in the park. I would just say, I'm just going to venture a guess of 8,000 bolts, somewhere in there, 7,000 to 8,000. So you can see we've done maybe a 7th or an 8th of those in 4 years.
I think that's likely to show up in our next park trivia quiz. Go ahead.
Yeah. So just one thing for people to know that are listening. So the Southern California climbing community in general has little to no interest in replacing fixed anchors. It's not done very often. It's not done in very many places. It's a lot of work, and people don't want to take the time. And then once again, like I said, we're very fortunate here that we have Mark, who's, designed and built all these tools at his own cost. And he spent a lot. I mean, he's the driving force behind the project. When he says I'm done, then our project is done. And then there'll be nobody replacing bolts in the park, or not on a regular basis. There might be the occasional person, but so yeah, the Southern California climbing community doesn't really have a great interest in doing this. We had some guys come out from LA. They want to start doing some stuff in the LA area, so they came out to see Mark's techniques and stuff. But the deal there is, unless you have his tools or the ability to build his tools, watching him remove the bolts is not super helpful, because you can't go back and do it yourself. And there's very few people I would guess in the United States that has their own, fabrication shop and their own ability to design and fabricate these tools. Now, it's not to say that there's replacement work goes on all over the U.S. and people have other tools that they've designed, but they're not to the quality of Mark's tools, and they don't have the versatility that his tools have. So this is a very unusual thing that we have out here. I mean, the people should feel pretty fortunate that he's committed all this time and his own money to make this happen. Any other questions?
Yeah, well, Dave points out that it's time to cultivate the next generation of bolt replacers here in the park.
Yeah, unfortunately, the people that climb don't have an interest in it, really. We get people who go out maybe once or twice, and then they see, and it's very tedious. There's nothing exciting about it. It's just very tedious, labor-intensive work, and you don't actually get to go climbing because it's all done on fixed ropes. So the general population, general climbing population doesn't really have an interest, at least from what we've seen or from what I've seen. And I've done this for a long time. I mean, I have a pretty good idea of what's going on. And, occasionally the American Safe Climbing Association, Greg, will say, hey, we have some people that want to come out and, go out with you guys. And so I go, okay, that's cool. And probably 50% of the time the people follow through, and the other 50% they don't. And, there's some financial commitment to people that help us. They have to have some of their own personal tools, which, a lot of the people may not have, and they don't want to, put out the money to do it. So it would be nice if other people were interested, and other people were interested in being very patient with the process, so we can do hole for hole, reduce the amount of resource damage. Because it's easy. I could go out and just hack things off and patch the hole and put a new bolt in. I mean, that's simple. Anybody can do that. But to minimize the resource damage, it's an art. It's an art form. It's not, and, it took Mark a while to perfect it, right? As we started seeing these different things, because there was all kinds of different bolts out there. And so not every technique will work on every bolt. So then we have to go back, or he goes back and he redesigns a new tool or technique. And then then we go back and take that one out. So. But yeah, if somebody's motivated to motivate other people, that would be cool. We'd be super psyched. Any more questions?
Right, different historical question. Kyle says,
Sure.
I know the early ethic for bolting in the park was ground up. Have you noticed any variance in the quality of bolts put in with this method? And is there any way for a climber to tell the difference?
There's no way for the climber to tell the difference. And that was the original, like when I put up roots, we would stand there and hand drill. So I would have to stand on some holes where I could take both hands off and still stand there and then hand drill. So you could hand drill an old 1/4-inch bolt, depending on the stance and the rock quality, anywhere from like 10 to maybe 25 minutes it would take to drill one bolt. And so, if you put up a root that had 5 bolts on it, it might take you 3 or 4 hours, just depends. But I'll tell you some of the other stuff we've discovered in the last 4 years, and that some of the people that have placed the most bolts have placed them in the worst rock, and they're some of the worst anchors we found. So it's very telling when you go back to these things and you see what people have done. It's very telling, and you don't know this until you actually go do this and you see all this stuff. So it's very concerning to us because of the amount of people that are using these fixed anchors now and the skill level of the people using them. You know, when me and Mark learned how to climb, everything was suspect and everything was dubious, but now everything's considered what people, they'll use the term bomb-proof. And I tell people never use that term because you don't know. You don't know what's happened to that bolt. Even bolts that we've placed, somebody could go and loosen them. Okay, all you need is a wrench. They could be hit by rock fall. I mean, you know, you don't know, right? So you can look at the bolt and you say, yeah, it looks good, but I just try and discourage people to use the word bomb-proof. And I always encourage people, if you can place your own gear, your old cams or your own passive protection, it's always better to do that because you know, you can see it and you know what it's doing and you know how good it is. So anyway, it's been pretty telling. I mean, if people went out with us on a regular basis, you would get to see, you know, some of the stuff that we find. And, you know, it's concerning for sure. Any more questions?
Looks like Dave Larson is going to get hold of you and start the new organization, GoBar, the Joshua Tree Bolt and Anchor Replacement.
Okay, we'll be good with that. I mean, yeah, so, you know, me and Mark think we might have another year or so in us. We started out going twice a week, and now we're down to once a week, sometimes maybe once a month, depending on, you know, how beat up we get on a particular replacement project. So it's, you know, it's definitely going to come to an end probably in the next year or two on our end for sure. You know, that'll be it. We'll be done with it. And, you know, we kind of we hope we can get to 2,000 bolts, but maybe we won't. Maybe we'll only get to 1,500. But that's 1,500 more than, you know, was done before. So, you know, we're super psyched on the amount of stuff that's been done and all the people that have helped us, you know, to get to this point. Like I say, it's not just, I mean, he's really the driving force, but there's other people that have been, you know, very helpful along the way. So it hasn't just been, you know, a 1 or 2 man project, and, you know, other people have been involved, you know, as well. Anything else?
Well, it's terrific work, and thank you for, you know, having this presentation to get the word out, because it seems like the more folks that hear about it, the more likely you are to find your replacement team.
Yeah, we'd be super psyched. We'd be super psyched that, you know, continue replacing and have other people replacing, you know, maybe not alongside us on the same formation, but, you know, finding their own formations and doing their own legwork, and then, you know, getting the permits and going out. And it would just be, you know, it'd be a good thing for the general climbing community to get involved with, you know, to make things better. But once again, it's an art. It's not just a simple matter of pulling a bolt out and re-drilling the hole. There's more to it than that. So that's the whole thing. And Mark's very forthcoming about, you know, showing people his techniques. But like I say, if you don't have the capability to build those tools, you know, it's not as helpful as you know, if somebody had those skill sets.
All right, and we have a question about Mark's last name.
Wagner.
Aha, Mark Wagner.
Okay, Kevin. Well, thank you for being here today, and thank you to our audience. Our next webinar will be this afternoon at 1 o'clock with Kurt Leusner on Birds of Joshua Tree National Park, Part 2. And I just want to give you a notification that we added another webinar for Wednesday, April 22nd, with Chris Smith and Jeremy Yoder, and they're going to be presenting the Joshua Tree Genome Project. And the Joshua Tree Genome Project aims to identify Joshua Tree genes responsible for adaptation to climate and to develop genetic information that will aid in the long-term conservation planning of Joshua trees. So until then, please stay safe and stay healthy. Thank you.